Okay, now we're going to practice balancing these equations, and I'm going to walk you through. The first thing that we're going to do for problem one, we're going to take inventory. Okay, we have sodium, oxygen, hydrogen, calcium, and bromine. All right, on my left side, I have 1 sodium. On my right, 1 sodium. On my left, 1 oxygen. On my right, 2 oxygens. You can see this 2 means I got 2 of those. I've also got 2 hydrogens over there. Okay. Now, hydrogen, I have 1 on my left side, and I have 2 on the right side. Calcium, 1 on the left, 1 on the right. Bromine, 2 on the left, and 1 on the right. Okay, so this doesn't look too complicated. I think what I want to do is I'm going to go ahead and put a 2 in front of NaOH. That's going to change my sodium to 2 on my reactant side, and it's also going to change my oxygen and my hydrogen to 2. So I'm really close here. In order to balance sodiums on my product side, I'm going to put a 2 in front of sodium bromide, and that is going to change my sodium to 2 and my bromine to 2, and therefore I've got 2 of those, 2 of those, 2 of those, 1 of those, and 2 of those. So we are in balance, and our coefficients will be 2, 1, 1, 2. All right, next one. I have potassium, bromine, iron, oxygen, and hydrogen. Now, one hint, as you get better at doing these, you see that hydroxide shows up in the same format in product and reactant sides. Because hydroxide is not breaking up, it's being reacted as a unit, we can actually count it as a unit. But for now, let me first do it the way I originally taught you, and then I will go back through and do it using hydroxide as a unit. So here we go. Potassium on the left side, we have 1. On the right side, we have 1. Bromine, on the left side, we have 1. On the right side, I have 3. Iron, on the left side, I have 1. On the right side, I have 1. Oxygen, on the left side, I have 3. On the right side, I have 1. Hydrogen, on the left side, I have 3. And on the right side, I have 1. Okay, clearly we're not in balance. I'm going to go ahead and I'm going to put a 3 in front of my KBr. That's going to give me 3 of these and 3 of these. Okay, and then I'm going to go ahead and put a 3 in front of KOH, and that's going to give me 3 of these, 3 of these, and 3 of these. And I think that'll do it. 3, 3, 1, 3, 3. Everyone's in balance. So our coefficients become 3, 1, 3, 1. Okay, let's go ahead and start this over again. Let's fix my K. Okay, we'll start this over again, but now this time we're going to use hydroxide as a unit. So I have potassium, I have bromine, I have iron, and I have hydroxide as a unit. All right, 1 potassium on the left, 1 on the right. 1 bromine on the left, 3 on the right. 1 iron on the left, 1 on the right, 3 hydroxides on the left and 1 on the right. First thing I want to do is go ahead and put a 3 in front of this number, in front of KOH, and that gives me 3 potassiums and 3 hydroxides. And that makes me want to put a 3 in front of KBr. And that's going to give me 3 of these and 3 of these. So here we are again. Everyone's in balance. And our coefficients become 3, 1, 3, 1. Okay, next up, we have C6H12O6, better known as glucose. Now, that little hint should be enough to help you remember how you learned this in biology. But in case you didn't balance this equation in biology, we're going to do it now. All right, we've got basically 3 elements. We've got carbon, hydrogen, and oxygen. On the left, I have 6 carbons. On the right, I have 1 carbon. On the left, I have 12 oxygens. On the right, I have 2 here and 1 here. That gives me, just counted oxygens, 3 of those. Hydrogens, I've got 2. And oxygens on my left side, I've got 6 here and 2 there. So I need to count 8 of those. All right, well, starting with carbon, I have to have a 6 in front of carbon dioxide because I have to have 6 carbons. There's just no way around that. So I'm going to change that to a 6, but that also alters the number of oxygens. That gives me 6 times 2, 12, plus 1 makes 13. Okay, so we're out of balance there, but we'll figure this out. All right, I see that I've got 6 times as many hydrogens on my reactant side as my products. So I'm going to go ahead, I'm going to put a 6 in front of H2O. That's going to, again, change things. 6 times 2 gives me 12 hydrogens. Good thing. All right. And then we have 6 hydrogens plus 12 hydrogens. 6 and 12 make 18. All right. So let's see what we have here. Okay, we only have 8 on this side, but we've got a nice even number. So let me go ahead and see if I can fix this. If I put a 6 in front of here, that'll give me 6 times 2 is 12, plus 6 more gives me 18. And there we have it, 6, 12, and 18. Everyone's in balance. So the coefficients are 1, 6, 6, and 6. All right, last one. Here we have silver sulfide decomposing to form silver and sulfur. Now, of course, I want you to notice this is S8. That's an interesting form of a molecule. That is a sulfur molecule with 8 sulfur atoms in it. So we don't get to change our subscript, remember. We want to, but we can't. Okay, so 2 elements. Oops, let's try the pen. Silver and sulfur. On this side, I have 2 silvers. On this side, I have 1. On this side, I have 1 sulfur. And on this side, I have 8. All right. Well, the first thing I want to do is go ahead and put an 8 over here. There's only one way I can get 8 sulfurs, and that's to put an 8 as a coefficient. So that's going to change my sulfurs to 8, and it's going to change my silver to 16. All right, and so I think I'm going to have to put a 16 here to change that. And here we go. I've got 16 silvers on each side and 8 sulfurs on each side. And that makes my coefficients 8, 16, and 1. All right. Thank you very much, and I hope that was helpful.